Let's see today's question. Given to us is a circle with center O. AB is a chord and there is a point P on this chord AB such that the length AP is 18 centimeter and the length PB is 8 centimeter. The distance of point P from the center O is 9 centimeter. From this data, we have to find what is the radius of the circle. Let's see its solution. So OP, if we'll extend this OP and let's say it's intersecting at point C and point D at the circumference. Now this CD is passing through the center of the circle. So CD is the diameter and CO is radius. If we'll check the length CP, now this CP is nothing but this CO plus OP, that is R plus 9, and the length PD, if we'll see OD is your radius R and if we'll subtract 9 from it we'll get the length PD. Now here further we'll use now chord intersecting theorem. So in this intersecting chord theorem, if the two chords are intersecting each other, then the product of the length of the chords, that is A times B, will be equal to C times D. So this intersecting chord theorem is discussed in video number 16, which you can check. And using this theorem, here we'll get the two chords are your AB and CD, and using the theorem we'll get PA times PB, that will be equals to PC times PD. Putting these values, PA is 18 and PB is 8. This is equals to PC, which is R plus 9, and PD is R minus 9. Simplifying it further, so 18 times 8 is 144, is R square minus 81. We'll take 81 on the other side, so R square is 225 and R, that's the radius of the circle, is 15 centimeter, and that's our answer. I hope you enjoyed the solution. So see you in next video. Till then, tata, bye bye.